Hi everyone. The objective of this video is to go through some of the key basics that you need to excel in Introduction to Economics. So the first thing that we need to understand is how the graphs work and how do you read them. So this is a simple x and y axis where, as you can see, when I go towards the right on the x-axis, the value becomes larger. When I go up on the y-axis, it becomes larger as well. As you can see, there are 4 quadrants in this. We only want to work with A because that's where all the positive stuff are. We don't really deal with negative stuff in economics. So I'm going to draw a line and name it y equals to mx plus c. C is basically the vertical intercept that you see there, and m is the gradient of the line. So it's the change in y over the change in x. So we call this m. So m is the gradient of the line, and if m is more than 0, you have an upward sloping curve. If it's negative, you have a downward sloping curve. If it's equal to 0, you have a horizontal line, and if c equals to 0 with m is positive, you have an upward sloping line. So that's how the gradient works. Okay, so moving on, if let's say we were to inverse the function, we can still give an equation to this line. It will be basically isolating x on the left hand side instead of y. The next thing that we're going to talk about is the dynamics of that curve that we just drew. We have got rotations and we have got shifts. Let's talk about shifts first. When we talk about shift, basically what it means is that the c changes, so the y-intercept is going to change. So as you can see, when it increases, it shifts up. When it decreases, it shifts down. What about rotations? It is basically a change in the gradient. If you have a higher m, you have a steeper curve, and you have a lower m, you have a flatter curve. So that's how the dynamics work. Well, the next thing that we're going to talk about are constraints. Now, there are certain functions that just love to go in a particular direction. For example, this curve just wants to go upwards towards the northeast direction, and there is a constraint over here, the red line, which actually stops it from going up higher. The next thing we're talking about is connecting graphs together. The reason we do this is because we want to see how one variable can react with 2 other variables. So that's why we connect graphs together. Like for example, this is vertically connection. This is a vertical connection, and we can also do it the horizontal way, as you can see right here. We now move on to differentiation, and we talk about the reasons why we will want to do differentiation in economics. One of the reasons is because we want to find out what's the rate of change given any function. So let's take for example y equals to mx plus c. This is a straight line, so we want to see what is the rate of change of y given x. So if we differentiate this, you will see that a unit increase in x will give m units increase in y. So therefore you have the gradient of the slope, which is equal to m. And since it's a straight line, the rate of change is the same throughout, it is constant. But what if you have a U-shaped curve where the gradient is different throughout? You take the function, you differentiate it with respect to x, you get this, and you basically just substitute the value of x, whereby you want to find out what is the rate of change at that point, you will get the rate of change. So for example, that was x naught. So that means the rate of change is equal to this. More interestingly, this is actually the equation of the line that is tangent to that particular point. So that's what we call the tangent line. And the next reason why we want to do differentiation is also to find out the maximum and minimum points of a curve. So take for example a U-shaped curve that looks like that. We want to find out what point of x is this curve at its minimum point. And if you can see, this is actually a tangent to the curve, which has a gradient of 0. So therefore, you actually want to find dy over dx equals to 0. You take the function, you differentiate it with respect to x, and you equate it to 0. And then you solve for x. So when you have this value of x, basically what we are saying is that b over 2a is actually the point whereby the curve is at its minimum. Please ignore the negative sign. Just imagine that we're at a negative quadrant or something. So let me give you an example. This is an example of a maximum point. As you can see, again, that tangent is basically where the gradient is equal to 0. So we differentiate y with respect to x, we equate that to 0, and then we solve for x again. So we know that the curve, the function is maximized when x equals to b over 2a. So that is another reason why we actually differentiate. Let's talk about some math language. When we say that y is a function of x, it basically means that y is affected by x, whether positively or negatively. So that's the language of math. We now go to some language of economics. So we want to learn what are the basic economic terms. The first thing that is important for us to know is exogenous and endogenous variables. What are these variables? Let's talk about a exogenous variable first, which is basically factors that are not included in the model. For example, M and C. These things are exogenous because when you plot it on the graph, they do not appear on the graph directly. As you can see, what is on the graph is actually X and Y, not M and C. So that's why when you change M and C, you actually have rotations and shifts. When you talk about endogenous factors, which is like X and Y, these are the variables in the model itself. You have a movement along the curve. For example, when X increases, you move upwards along this curve. So therefore, endogenous factors result in movements along curves. We need to talk about real versus nominal variables. And just to give you an example, we've got real income, real interest. And the reason why we need to differentiate between real and nominal is because this affects our decision making in any economic model. For example, quantity demanded in terms of goods or the money demanded, consumption, investment, etc. All these things depend on real or nominal variables. The concept for equilibrium is a very simple one. It is basically the point where economic forces balance and they do not change. So economic forces, for example, could be demand and supply, where when they equal to each other, that's what they mean, that is by being balanced. And when I say do not change, we have a time frame. We usually talk about the short run and the long run, whereby in the short run some variables are fixed, and in the long run these variables are now flexible. So these are the economic terms. In economics, we make a lot of assumptions, and the purpose of this is to make the model easier to understand. One of the key assumptions in economics are that individuals, economic agents, are rational. We basically make use of all the information available to us, and we are selfish people when we just want to benefit ourselves. Basically, economics is easy as long as you're consistent, you read a bit widely, and if you study with Quickienomics.